Okay, for this part, we are doing the factorization using algebraic rules. So in the expansion part, I already kind of mentioned that when we reverse the algebraic rules, it will become a factorization. So out of the three uh, algebraic rules, right, this is the one that is more difficult. Okay, so we're going to reverse this. We're going to reverse this to make it into a factorization. So which means, right, if you can see a square minus b square, it will be factorized into the two brackets. Okay, so it might seem very simple, but you must have an awareness that a and b, right, can be very big. So it's not going to be so direct. Okay, so of course, I'm going to show you a very basic one first. So if you look at example 6a, it'll be something like x squared. You need to know perfect squares. So for example, 49 is 7 squared. So if you do this, right, you should be able to recognize that A is x, B is 7. And then you return back to the formula. So it becomes x plus 7, x minus 7. And obviously you can check back. Okay, you can check back by doing your rainbow or arrow method. So you can do your rainbow or your arrow method to see that it actually get you back to the same x squared minus 49. Okay, so this one is one of the basic one. Okay, here, the next one starts to get a bit more complex. Okay, for this one, right, I show you the correct answer first, and I show you what are the typical wrong answer that people will give. Okay, so this one, right, 4 is a perfect square. 81 is also a perfect square. So it should be, so you gather the double square. So 2 square and x square will actually become a 2x square with a bracket. So when you do this, you should recognize that A is 2x, B is 9. So if you got back, returned it to the formula A plus B, A minus B, you should have gotten this. So this is the correct answer. So if you do your rainbow method, you will get back the 4x squared minus 81. Okay, so I will show you the common mistake that a lot of students will give me. So a lot of students will recognize that 81 is a perfect square. So a lot of students will give me this. So when the student gave this, they are telling me that A is 4x and B is 9. Okay, and if this student go and check back with the arrow. So the student will be getting something like this. 4x and 4x, that will be a 16x squared. Then minus 36x plus 36x minus 81. So the students will somehow get this if the student bother to check back. So apparently this one is wrong. Okay, so a lot of students will actually make this mistake and they wouldn't know that why they are wrong. To know why you're wrong, very simple. You just check back, expand out the factorization that you gotten. Okay, so that's one of the common mistake. Okay, same thing, all this, right? Okay, we'll have a little bit of the squaring is not so obvious. So for example here, okay, where you see x squared over 100. So at 100 is 10 square. 25 is 5 square. So there's a double square here. From the double square, it will become a x plus 10 square. And then a 5 square. So at this moment, your A should be a x over 10. Your B will be a 5. So you apply the formula direct. A plus B and A minus B. Again, you can do out the expansion. I let you do it. I'm not going to do it up for you. Okay, you work back your arrow method. Okay, so what you need to show all this working, right? Actually, no need. If let's say you can mental, you actually can mental the answer straight away. Okay, so maybe some of you may be wondering, will you encounter numbers that are not perfect square? Yes. So in the upper side, sometimes we don't have a perfect square. So we actually make use of square root. But for set 2, if you see, like, for example, 5 is not a perfect square, 1, 2, 5 is not a perfect square. So this example is a mix of two methods. That means, right, I actually do a take out common factor first. There is a common factor that you actually can take out. So 5 is my common factor. So after I take out the common factor, I realize that my 25 is a 5 square. So this match the formula. A equal to X, B equal to 5. So you return back the formula. So this part will be a X plus 5 and a X minus 5. So if you use your expansion to multiply back, you should get back the 5x squared minus 125. So this one, sometimes a lot of students will actually find it difficult. So if you can actually mentor this, that means you actually see the idea. But those who cannot mentor, not to worry, but you must learn to apply the formula. Okay, so this one is just basic application of the formula. Okay, I will show more difficult one in example 7. So in example 7, right, things get slightly more challenging. For example, you will see a x power 4. So when you see a x power 4, it's actually a x square square. And it's a y square square. So your job is to realize that this is your current A. So this is your B. So it will be your A square minus B square. Return it to the formula. So x square, A plus B, and then A minus B. So most students will stop here. If you can come to this part, right, you're actually correct already. But your teacher will give you a carrot because this part actually fulfill the same formula. The x square minus y square fulfill exactly the same formula. So you're actually going to repeat the formula one more time. So you repeat the formula, you'll get a x plus y, x minus y. So example 7a, make you factorize twice with the same formula. Okay, so it makes you factorize twice with the same formula. Okay, the other one, 1 minus x squared. So some of you may not know that 1 is the same as 1 square. 1 square is like 1 times 1. So 1 is essentially the same. And 9 is a perfect square. So you can see a double square. So when you can see a double square, if you look carefully, you can see that A is 1, B is 3x. From here, you plunge it back to the formula. A plus B, A minus B. Okay, do you need to show all this working right? Actually, no need. You can just do a mental factorization. Okay, the next two questions will be a bit more confusing. Okay, so we are doing a factorization in this question. Okay, so you focus on factorize. So I will show you the correct answer first, and I will show you what student will actually give me. So 9 is a perfect square. X plus 1 is also already a perfect square. So this is a situation where A is equal to 3, B is equal to X plus 1. So, which means, right, if I return to the formula, it will be A plus B and A minus B. So I return to the formula, A plus B, A minus B. Within the square bracket, do you realize that you can actually simplify? So within the square bracket, I'm going to simplify and I will get the nice two brackets. So this is the correct answer. Okay. Some students in exam, right, they will unknowingly do this. Okay, I'm going to tell you this one is wrong. Okay, as I'm going to show you this, right, do you think you can understand what went wrong? So why is it wrong when a student do this? So if a student do until here, right, why do you think the student is wrong? Because the student is doing expansion. The student is not doing factorization. Okay, so this student is wrong. I will mark the student wrong because the student never factorized. The student is just expanding it up, and the student expand using the formula. Okay, but the instruction is not expanding. The instruction is factorized. So what could have the student done instead? So if a student, right, realize that, oh, okay, after expanding, right, actually the student, if let's say the student continue with the cross method or the tic-tac-toe and still comes out with the same answer, then the students will get it correct. So if let's say the student stop at the green part, then the student is wrong because the student is doing expansion. But if the student continue with the cross method or the tic-tac-toe method, then the student actually got it correct. So the student did an expansion followed by factorization. As long as the answer is the factorized format, then it will be correct. Okay. So for D, right, it's exactly the same thing. So D, a lot of students, right, for those who never read instruction, they just do blindly. So some students, right, will just expand out. So when a student see this, right, and if they don't look at the instruction, then they will go and do the formula. Okay, so the student is actually doing an expansion. Okay, so I won't work it out for you. Okay, so the student will be doing an expansion. I think I just work it out so that you can see. So it seems like nothing is wrong. The student is like, oh, doing the expansion, but the instruction is actually a factorized. Okay, so what you can do? So you will get 8x. No, sorry. You will get a 6x. You will get a 6x minus 3. So until here, the student will be wrong because the student never factorized. But the student actually can continue and factorize. Then that will be correct. So for C and D, you have the option. You can go through the expansion followed by a factorization. But if you stop at the expansion part, okay, you will be wrong. So if you just do the green color part, you will be wrong because you are doing expansion. You're not following the instruction. Okay, so if let's say if let's say I don't prefer to expand out, is there a shortcut? Actually, there's a shortcut. This is the A. This will be the B. So my A is, okay, I think I put the equal sign here. My A will be x plus 1. My B is the x minus 2. So I'm going to do the formula. The formula says A plus B. But my A is a little bit huge. Doesn't matter. A plus B and A minus B. It looks huge, but it's actually very easy to simplify. You look at each of the bracket. It's actually very simple. Like for the first bracket, you already got 2x minus 1. For the second bracket, the x is cancelled out and you got a 3, which is exactly the same answer if you have gone for the expansion, then take out common factor. So will you get both correct? Yeah, you will get both correct. Doesn't matter. But it's just that if you use the a square minus b square in this situation, it's actually shorter. You cannot be doing the green color part only. If you do the green color part, you get no mark because the instruction is factorized. That's why sometimes when some of you text me to ask questions, they will show me an algebra expression. So I will be asking you, is it expansion or factorization? So different instruction will do differently. Okay, so some of you never tell me instruction, so I actually know that you don't really go and read the instruction. So you get yourself very messed up if you don't read the instruction, especially in a test, algebra test, they are just going to mix up everything. So you just have to take note. Okay, so this one, for part E, if you look at part E, your job is to factorize. It's quite challenging to factorize this, if you can see. It's quite challenging. And how is it related to this formula? How is it related to this formula? Right. Okay. So if you have done we already done the grouping. Okay. So in grouping, okay, this is like grouping. So usually grouping will be this one is the first group and this will be the second group. So if you have done grouping, you realize that grouping need 4 items. So when you have 4 items, like the first 2 is one group, the second 2 is one group. Okay, so I'm going to group them. So I'm going to group them this way. I change the equal sign to here. So from the first group, I actually see a common factor. Okay, I don't know whether you can see. Okay, let me cancel this part here. So from this first group, I can see a common factor. From the second group, I do not see a common factor, but I can factorize out a negative. So you realize this one is a little bit like the grouping. So when you do the grouping and you found a common bracket, that means your grouping is correct. So there is a common bracket for you to factorize out. And you are left with x minus 1. So that's not the end yet. Most students will stop here. They forgot that this can be continued with x squared minus 2 squared. Which means, I'm going to be using the formula here. So I actually can get a plus b, a minus b, and my last bracket is x minus 1. So I successfully combine grouping and the formula. So if you look carefully, I mix grouping and this formula, and I managed to successfully factorize out. So just now in one of the previous example, there is also a take out common factor before we use the a square minus b square formula. So everything can mix together. The four methods can be rolled out and mixed together. Okay. So this will be the a square minus b square formula. And there's actually more difficult one. Okay, when you go along. Okay, so look through the idea of a square minus b square. So we just to filter out the a and b and plug back into the formula. So if you can do this mental, right, you just do mental. You don't even need to show any working. Okay, but it's just that we will combine with other methods.